Hello everyone, in this video we are going to be solving for the solutions to systems algebraically using substitution and elimination. First we'll start with substitution though. The rule is, if you're going to use substitution, is that one equation must be equal to a single variable. It could be equal to x or it could be equal to y. In this case we have two equations that are both equal to a single variable, and that single variable is y. So when we have two equations equal to y, we just go ahead and circle one and substitute it in for the other. So in other words, this helps me out a lot. If y is equal to y, I could put a little equal sign in between there. Y is equal to y. That means 3x must be equal to 6x plus 20. And that'll help you see exactly what to do to set up this new equation. So y is equal to y. 3x minus 10 is equal to 6x plus 20. So now all we have to do is solve for x. Now we have x on both sides of the equal sign, and we are going to subtract 3x on both sides. We kind of like to stay in the positive, so that means I'll always try to get the smaller x over to the larger x. This cancels, and then we have negative 10 equals 3x plus 20. To solve for the rest of this equation, remember you have to isolate the variable, and in this case the 3x plus 20 is on one side. We're going to bring that positive 20 over, and by using inverse operations subtract 20 on both sides. Negative 10 minus 20 is negative 30, and you bring down the equal sign. You also bring down the 3x. You divide by 3 as a last and final step. The 3's cancel. X equals negative 10. So you have, as part of your solution is always in coordinate form. So you have to have it in x comma y form here. So this is negative 10, but we don't have a y. So we're going to pick one of these equations, and it doesn't matter which one we choose. You can pick the first one or the second one, and you can substitute the x, your x of negative 10, into one of these equations. I'm going to pick the second equation because it doesn't have any like subtraction symbol, but you can pick the first, it's fine. So I'm going to write down y equals 6, and instead of the x I'm going to substitute the negative 10 in. So we have y equals negative 60 plus 20, and finally y equals negative 40. You can put that in your calculator, and you can see the solution is negative 10, negative 40. That is your answer. This is what you are asked to find. This is the intersecting point of both of these lines. If you graph them, you would see them intersect at negative 10 and negative 40. Right? And so let's go on to another problem. So this is still substitution. We're still going to use substitution. So the rule is that one equation must be equal to a single variable. That one equation is this one. The second one is equal to a single variable. So now you know how I put the equal sign in the middle here? They're not equal to each other. Not. 7x is not equal to x. So that means that you can't set anything equal. You have to use substitution. Since this 3y, and I'm going to circle it, 3y plus 20 equals x, I'm going to go ahead and substitute that 3y plus 20 right in for x. So I already set up this equation right here. So you see this 7x minus 15y equals 32. This is x. 3y plus 20 is x. So what I'm going to do is I'm just going to take this x. This is equal to x. The expression 3y plus 20. And I am going to take this and then substitute it right in for x. Right? And so now I have all y's. You notice that this is a y and this is a y. Now you could solve this equation, right? Because you can't solve an equation with two different variables. So you go ahead and you now use distributive property. So this is 21y plus 140. 7 times 20 is 140. Then you bring down the minus sign and the 15y equals 32. You have to combine like terms. And the like terms that you're going to combine are 21y and the negative 15y. They're on the same side of the equal sign, so you just combine them. So you have 21 minus 15, and so you have 6y. Bring down the 140 equals 32. Finally, you subtract 140. You're starting to isolate that variable, and we are going to cancel. This 6y comes down, equals negative 108. And then you divide by 6, and just remember, use your calculator, divide by 6, you get negative 18 as an answer. This cancels, y equals negative 18. So just like before, okay, we have a solution, but the solution is only half done. So we're going to put the solution in coordinate form. We have negative 18 as the y, but we don't have an x. So obviously you're going to pick the second equation because it's already equal to x. So we have x equals 3 times y. 3 times y is negative 18 plus 20. Grab your calculator and you're going to put 3 times negative 18 plus 20 in, and you press enter and you get negative 34. All right, so x equals negative 34. We have a solution. So negative 34 comma negative 18 is where these lines intersect. All right, so let's go to elimination. Elimination works a little bit easier. I think it's easier than substitution. Is that you look to eliminate one of the variables. All right, so that means they have to have opposite coefficients. The number next, the number that is in front of the variable has to be the opposite of the one directly below it. So in this case, we have 8x plus 11y equals 20, and then 5x minus 11y equals negative 59. You just take a look. The 8x and the 5x do not cancel, but the positive 11y and the negative 11y, they do cancel. So what you're going to do is it's almost like you're adding all of this, but I don't usually put the plus sign there. I just go by the signs that are before the number. So a positive 11y and a negative 11y, that cancels. That's 0. So 8x plus 5x is 13x, right? Equals, and then 20 minus 59, 39. Then you divide by 13 and look at this. X equals 3. X is done already. You're finished. So let me go over here, solution. We only have 1/2 of it. We have 3, comma, we don't know what the y is. So now my job is to actually just pick one equation that I think is easier to work with to solve for y. I think that equation is the top one, the first one. And I'm going to substitute in for x, this x right here. I'm going to substitute this 3. And I'm going to rewrite the whole equation. I'm going to have 8 times 3, which is 24, plus 11y equals 20. Yep, so I just realized that I did make a mistake, and just here's the mistake right here, right? 20 minus 59 is negative 39, and that would turn this to a negative 3, and that makes a difference right here. This is a negative 3. This is a negative 24. It definitely makes a difference. All right, so just make sure that you don't make the same mistake I just made. 20 minus 59, negative 39. All right, so now you would just go ahead and add 24 to both sides. And just remember, this solution was negative 3, not positive. This cancels. And then you have 11y equals 44. And you divide by 11 on both sides. Divide by 11 on both sides, and you have y equals 4. And that's the solution, negative 3, 4. All right. Try not to make a mistake. Check it. I was rushing. And there you go. That's the reason why the positives and the negatives are so important. Right? Anybody can make those mistakes. Just check your answer and you'll be okay. All right, just one more elimination problem. When you're looking for elimination, one equation, no, this is for substitution. So elimination, one equation must eliminate, right? One variable must eliminate with the other. So we have 3x and 4x. That doesn't eliminate. 10y and 40y. That doesn't eliminate. So what do? Well, we just try to get one to eliminate by using distributive property, multiplication. Right? What can I multiply here? This first equation by to get this 10y, this negative 10y, to be the opposite of positive 40y. I need a negative 40y. So what can I multiply? What number here should I multiply to get this to a negative 40y? Yes, it is 4. So just take a look. If I do distributive property, and I have to do distributive property to all 3 terms inside the parentheses, it is 12x minus 40y and then equals negative 100. That's exactly what it is. But now I'm going to rewrite the equation on the bottom, 4x plus 40y. Notice that the y's are going to cancel now, and then this is 20. So here we go. This cancels. This is 16x, and this is negative 80. When you go ahead and solve, and you bring up your calculator, always use your calculator, and we get x equals negative 5. So now the part of the solution is negative 5, comma, something. So I'm going to look at the 2 equations and I'm going to look to see which one looks easier to me. And I'm looking at the second equation. So I'm going to rewrite this. 4 instead of x, I am going to put -5 because that was what I solved for. So 4 times -5 is -20 plus 40y equals 20. You add 20 on both sides, and this cancels. You get 40y equals 40. Divide by 40 on both sides, and y equals 1. So the solution is -5, 1. And that is elimination. So to review, substitution. When you're using substitution, there has to be at least one equation equal to a single variable. Doesn't matter which variable it is. It could be x, could be y. If they're both equal to y, or they're both equal to x, both equal to the same, that means their expressions are both equal to each other. You could just set them equal to each other and solve. In this case, we used substitution as well, and we had only one equation equal to a single variable. So I circled that expression, and then I substituted in for the x, and I showed you that here, solved for x and solved for y, and then substituted back into the easier equation already solved for x to get the x. For elimination, one variable must be opposite the other. Not so much the variable, but the coefficient attached to that same variable must be opposite the other. And in this case, 11y is opposite of -11y. And that's what cancels out without you doing anything. That's 11 minus 11 is 0. So that's why it cancels. And then you just add everything down and you solve for x here. And don't forget to substitute into the one of the equations to get the other variable, which in this case was y. And the last one, remember, one variable must be opposite the other, and in this, there's nothing that's opposite. So we wanted to change this. We're looking at this 40y here. What is the opposite of positive 40y? Well, negative 40y. So that means I would have to pick 4 to multiply this whole equation. Can't just multiply one part of it. The whole equation to make it -40y. When we finished, we solved for y, and then we picked the equation here to solve for the other variable, in which case this was x. The solution was -5, 1. Hopefully that helped you out. Thanks for watching.